Hello everyone. Today we are going to discuss the electrocardiogram, ECG or EKG. Investigation of cardiovascular disease. There are many investigations. Some are the basic tests like ECG, cardiac markers, chest X-ray, and echo. These are the basic tests. They occur in almost all patients in the bedside or the outpatient, and they are less time consuming. These four tests like cardiac catheterization, radionuclide imaging, CT and MRI, these are complex procedures. They are not done in all patients. They are done in specific patient or specific diseases. In this video we will focus only on ECG. Now electrocardiogram, ECG, is used to record the electrical activity of the heart from the different angles. You know that the heart consists of the muscles and the electrical fibers like the SA node, AV node, bundle of His, right and left bundle branches, and the Purkinje fibers. These are the electrical signal travel in these muscles and these electrical fibers, and this electrical activity is picked up by the ECG machine and is shown on the ECG paper like this in the waveforms. This is the graphical representations. And okay, ECG lead. ECG lead, when it is very important. ECG lead is a graphical representation of the heart electrical activity generated from several electrodes. This graphical representation is called, these are the ECG leads. Now this is the normal ECG pattern, P wave. You know that the heart consists of the atria and ventricles. The SA node fire, it depolarizes the atria. This atrial depolarization produces the P waves. The P wave is produced from the atrial depolarization. When the atria depolarized, P wave is formed. Next is the PR segment. PR segment, it is a flat line like this. You know, it is a flat line, you see, and it is the between the end of the P waves. P wave end here and the Q waves start here. QRS start here, the P wave end here. The segment in between this is called PR segment, and PR segment shows the electrical activity in the it is showed the electrical activity of the AV node. The AV node electrical activity is very slow, and it is slow and it is not picked up by the ECG machine. So you get this flat line. Flat line means there is no electrical activity. This is the borderline. Borderline means no electrical activity. Upward deflection is positive electrical activity, and the negative is downward deflection, and upward is the positive deflection. Okay, so this is the PR segment. Now is the QRS complex. When the electrical activity reaches the AV node, then it reaches the bundle of His, bundle branches. This is the left, this is the right, and this is the Purkinje fibers, and then it reaches the myocytes. When the myocyte depolarizes to this electrical fibers, it produces the QRS complex. QRS complex means that the ventricle, it shows the ventricle depolarization. Okay, so ventricle myocardial depolarization, QRS complex. Then is the ST segment. ST segment is the end of the QRS complex. QRS complex end here, and the T wave start here. So segment in between this is the ST segment. Okay, now is the T wave. T wave is the when the ventricle depolarize, when the ventricle repolarize, it form the T wave on the QRS complex. This is the when the ventricle depolarize, it has to repolarize. This repolarization produces the T wave. Now there are two interval, PR interval and QT interval. PR interval is the interval between the onset of P waves, and the onset of QRS complex. Onset of QRS, in between this is the PR interval, and second is the QT. QT, it is the total duration of the ventricle depolarization and the repolarization. So ventricle depolarization start here, QRS complex, and it end here. It is the end of the repolarization, T wave. So it is the segment in between them is the QT interval. Now the 12 ECG lead. The ECG machine consists of the 10 electrodes. It consists of the 10 electrodes. 6 are the chest leads. You know, this is the 6 V1, 2, V6 are the chest leads, and 4 are the limb leads. One lead is placed on the skin of the right arm, and the second one is the left arm, same as the right leg and left legs. So these are placed on the skin of the limbs. So there are 4 limbs and 6 precordial leads. These 3 are very important. The right leg is the earth negative, so it is not very important. These 3 are very important. Now the second thing is the leads. These are 10 electrodes of the ECG machine, which is placed on the skin. It gives us the electrical activity of the heart from the 12 different angles, 12 different sides. Its combination gave us the electrical activity of the heart from 12 different sides. Is very important. So we will discuss each of them. So these are all the 12 electrodes, all the 12 leads of ECG are which is created from the 10 electrodes is shown on the ECG paper here. This is you can see we will discuss each of them. Now the 12 ECG leads, there are 6 limb leads and 6 chest leads. Okay, as I previously discussed, there are 6 chest electrodes and 4 limbs electrodes, and these 10 electrodes produce the 12 leads ECG, 12 different angles of the ECG. Okay, so there are 6 limb leads and 6 chest leads. The limb leads are divided into 2 more parts. The leads 1, 2 and 3, these are the bipolar. They use 2 electrodes to create one pattern of the ECG. And the leads AVR, AVL and AVF are the augmented or unipolar voltage limb leads, and V1 to V6 are the unipolar chest leads. The limb leads record the ECG in the frontal or the vertical plane, and the chest leads occur in the horizontal plane. You see the limb leads record in the vertical plane, like from the left, from the right, from the inferior foot, from foot side, like inferior, you see at a 90 degree, and here is the lead 3. And V1 to V6, they record the electrical activity in the horizontal plane. You see this is the horizontal plane. Now we will discuss each leads. Leads 1, 2, 3, as I discussed, these are the bipolar. How are they bipolar? How these leads are formed? Like for the lead 1, the electrodes placed on the right arm and electrode placed on the left arm. The right electrode is negative for lead 1, and the left electrode is positive. So there is this basic principle that the current flow from the negative electrode to positive, from the negative to positive. So you get this lead 1, and this is the ECG pattern of the lead 1. And it is like the lead 1 is looking your heart from the left side or the left arm. Now lead 2, the right arm is a negative, right arm electrode is negative, and the leg electrode is positive for the lead 2. So current flow from the right electrode to the left leg electrode, which is positive. So you get this lead 2 ECG pattern, you see. And the third is the lead 3. The left arm acts as a negative, and the left leg electrode acts as a positive. So current flow from the negative to positive. So you get this lead 3, and this is the ECG pattern of the lead 3. Now this graph is very important. This is the circle and the 360 degree circle. So this is the 0 degree, the reference 0, and any electrode or any current which flow in a horizontal from the right to left. This is the left, this is left, and this is right. From the right to left in a straight horizontal line, you get the that electrode, that lead will be at the 0 degree, like the lead 1 flow in a straight line, straight horizontal. So lead 1 will be at 0 degree. For the lead 2, it look your heart from the inferior left angle. So for the lead 2, this flow in this direction. So you get this lead 2 will be at the 60 degree, and lead 3, it look your heart from the inferior right side, and it flows in this direction, so it occur lead 3 is there is at 120 degree. Okay, now leads AVR, AVL and AVF. A mean augmented, V mean vector, R mean right. This is left, then this is foot. These are the augmented leads. Augmented mean enhanced. Their electrical activity is enhanced or more than the leads 1, 2 and 3. And these record electrical activity between a limb electrode and modified central terminal. So what this term mean? Let's suppose if we take lead AVR, the right arm is the positive electrode, the left arm and the left foot is the negative, and the average of these two negative act as a central terminal for the AVR. So current flow from negative to positive. Okay, and for the lead AVL, the left arm is the positive and the right and the left foot are the negative, and their average negative, the current flows from their average negative to this positive. And for the AVF, the foot electrode is positive and these two are the negative, so current flow from their average negative toward the left foot. Okay, now this circle for the AVR, the average current flow for into this in this direction, so the angle for the AVR will be 1 minus 150 in the anti-clockwise, and it shows that this electrode look your hard in this angle. Okay, now for the AVL, its direction, it make its direction. Now for the AVL, it is at the angle of minus 30 degree, and for the AVF, it is at the angle of 90. You see, it is 9 straight downward, so it make 90 degree angle. Now the QRS is negative in AVR. So why it is negative? Because this is the ventricles, and the normal vector of the ventricle, the direction of the normal ventricle and the direction of the normal vector of the ventricle is down and to the left. It is at the 60 degree. It is at the 60 degree, and the AVR lead direction is upward. It is against this. So it will give you a negative deflection in the ECG. So that is why it is negative. And the QRS of the AVL is isoelectric, because this vector, the vector of this lead make an angle of 90 with the normal QRS vector. So when there is 90 angle, it will give you an isoelectric QRS. Positive and negative both are equal, both represent positive and negative, and both are equal. And the QRS of the AVF is positive because it is almost in direction of the QRS vector. It is almost in the direction of the QRS vector in the AVF, so that's why it is positive. Now the chest leads V1 to V6. V1 is present in the fourth intercostal space and in the right margin of the sternum. V2 is for fourth intercostal space in the left margin of the sternum. V4 is in the fifth intercostal space, mid-clavicular line. This is mid-clavicular line, and V3 is placed in between these two. V3 is placed in between V2 and V3. V5 is placed in the fifth intercostal space, and it is in the it is present in the it is present in the anterior axillary line. Okay, and V6 is placed in the fifth intercostal space in the mid axillary line. So V4, V5, V6, they are in the fifth intercostal space. Okay, chest leads record electrical activity in the horizontal plane. So this is the horizontal plane, this is a slice. Okay, and these are V1 to V6, these are all positive electrodes. These are all positive, and their negative is the and their negative is the made by the average of these limb electrodes, and their negative is made by the average of these limb electrodes. So their average make a negative in the center, so it acts as a central for the chest leads. Okay, negative central for the chest leads, and these are the ECG pattern of the chest leads. Okay, V5, these are the highest amplitude because of the ventricular mass is greater than the auricle. Okay.